Before our modern age of medicine, the world was honestly a far more dangerous place. A simple cut from a kitchen knife, a scrape on a child's knee, or even just a sore throat could quickly become a death sentence. People lived in constant fear of infections, which were common, and, more often than not, impossible to stop. A small wound could swell, turn red, and fill with pus, leading to a raging fever that no doctor could control. Childbirth, which should have been a natural part of life, was incredibly risky for mothers, who often died from infections contracted during delivery. Hospitals weren't really places of healing, but often places where people went to die, as infections spread easily from one patient to another, with no effective way to fight them. For thousands of years, people tried desperately to find ways to combat these invisible killers. They turned to what nature provided, using ancient remedies passed down through generations. Honey, with its natural antibacterial properties, was applied to wounds to keep them clean. Certain herbs and plants were brewed into teas or ground into pastes, believed to have healing powers that could drive out sickness. In some cultures, people even used moldy bread, pressing it against infected sores. They didn't know why it sometimes worked, only that it seemed to help. These early attempts were a shot in the dark, a desperate hope against overwhelming odds, with successes that were, honestly, few and far between. Imagine a family watching their child suffer from a high fever, caused by a simple ear infection. They would try every folk remedy they knew, from cool cloths on the forehead to special soups and prayers. But these methods were powerless against the bacteria multiplying inside the child's body. Doctors of the time had very few tools. They could clean a wound and stitch it closed, or, in the most extreme cases, amputate a limb to stop an infection from spreading through the entire body. This brutal reality meant that life was fragile, and the loss of a loved one to a common illness was a frequent and heartbreaking event for families everywhere. This constant threat shaped everyday life in profound ways. People were cautious, knowing that any injury could lead to a serious illness. The death of children was sadly, a tragically, common occurrence, and many parents had to endure the pain of losing a child to diseases like scarlet fever, pneumonia, or meningitis. The average person did not live nearly as long as we do today, not because of old age, but because their lives were often cut short by infections that we now consider minor and easily treatable. This was the world before antibiotics, a world where humanity was largely defenseless against the microscopic organisms that could take a life in a matter of days. For a very long time, no one really understood what caused these deadly infections. People blamed bad air, imbalances in the body, or even supernatural forces. Sickness was a mystery, a terrible event that seemed to strike at random. Without knowing the true enemy, it was impossible to develop an effective defense. Doctors and healers were essentially fighting blind, trying different treatments without understanding the fundamental reason why people got sick. This lack of knowledge was a huge barrier to medical progress, keeping humanity locked in a cycle of disease and premature death for centuries, unable to see the real cause of their suffering. The big change began in the 19th century with the work of pioneering scientists like Louis Pasteur and Robert Koch. They introduced a revolutionary idea called germ theory. Through careful experiments, they showed that many diseases were not caused by mysterious vapors, but by tiny living things called microorganisms, or germs. Pasteur proved that these germs were present in the air, in water, and on surfaces all around us. Koch went a step further, identifying the specific bacteria responsible for deadly diseases like anthrax and tuberculosis. This was a monumental breakthrough that changed medicine forever. For the first time, science had identified the invisible enemy. Once scientists knew that bacteria were the culprits, the race was on to find a way to kill them without harming the patient. This was the central challenge. They needed something that could target and destroy the invading germs while leaving the person's own body cells unharmed. This concept was known as the magic bullet. Early researchers experimented with various chemicals, looking for a substance that would be toxic to bacteria but safe for humans. It was a difficult and often frustrating search, with many failures along the way. But the goal was clear, and it sparked a new era of scientific investigation aimed at conquering infectious diseases. This new understanding of germs led to immediate changes in public health and medicine. Doctors started washing their hands between patients and sterilizing their surgical instruments, dramatically reducing the spread of infections in hospitals. Cities began building better sewer systems and ensuring cleaner drinking water to prevent the spread of diseases like cholera. These measures saved countless lives, even before the first true antibiotic was discovered. The knowledge that germs cause disease was the essential first step, laying the foundation upon which the entire field of modern medicine would be built and paving the way for the miracle that was to come. The discovery of the first true antibiotic was not the result of a deliberate, planned experiment. Instead, it was a moment of pure luck combined with a prepared mind. It happened in 1928, in the London laboratory of a Scottish scientist named Alexander Fleming. Fleming was known for being a bit messy, and before he left for a vacation, he had left several Petri dishes with bacteria growing on them stacked on his lab bench. When he returned, he noticed something unusual on one of the dishes. A spot of blue-green mold was growing on it, and all around the mold, the bacteria had been completely destroyed. Fleming was intrigued by this strange sight. Something in the mold was clearly stopping the bacteria from growing. He correctly guessed that the mold was producing a substance that was lethal to the bacteria. He took a sample of the mold and identified it as a species of Penicillium. He named the substance. It produced penicillin. Fleming conducted further experiments and found that penicillin was incredibly powerful, able to kill a wide range of harmful bacteria. Even more importantly, it seemed to be harmless to human cells, making it the magic bullet that scientists had been searching for so long. However, turning this laboratory curiosity into a usable medicine was a massive challenge. Fleming found it very difficult to extract the active ingredient, penicillin, from the mold and produce it in large enough quantities to treat a person. For over a decade after his discovery, penicillin remained little more than a scientific curiosity. He published his findings, but the world was not yet ready to grasp the full potential of his discovery. The substance was unstable and hard to purify, and without a way to make a lot of it, it couldn't be used to save lives on a large scale. The true potential of penicillin was finally unlocked during World War II. With soldiers dying in huge numbers from infected wounds, the need for a powerful antibacterial drug was urgent. A team of scientists at Oxford University, led by Howard Florey and Ernst Chain, picked up Fleming's research. They developed new methods to purify penicillin and, with funding and support from the American government, figured out how to mass produce it. By 1944, enough penicillin was being made to treat all the Allied soldiers wounded on D-Day, saving thousands of lives and proving its incredible power. The success of penicillin during the war kicked off what is now known as the golden age of antibiotics. It was, honestly, a time of incredible optimism and rapid discovery in medicine. Scientists realized that if one type of microorganism, like the Penicillium mold, could produce a life-saving drug, then others must exist in nature as well. They began a worldwide hunt for new antibiotic-producing microbes, searching in soil samples from all over the globe. This massive effort led to the discovery of many new antibiotics in the 1940s and 1950s, each capable of fighting different types of bacteria. This flood of new drugs fundamentally changed the practice of medicine. Diseases that had once been terrifying killers were suddenly treatable. Pneumonia, scarlet fever, meningitis, and syphilis could now be cured with a simple course of pills or injections. The average life expectancy soared as people no longer died young from common infections. For the first time in history, doctors had a reliable way to stop bacterial diseases in their tracks. The development of streptomycin, for example, provided the first effective treatment for tuberculosis, a disease that had claimed millions of lives for centuries. It felt as if medicine had finally conquered one of humanity's oldest enemies. Beyond curing diseases, antibiotics made entirely new medical procedures possible. Complex surgeries, such as open-heart operations and organ transplants, became much safer. Before antibiotics, the risk of a patient dying from a post-surgical infection was extremely high. With antibiotics to protect them, surgeons could perform longer and more intricate procedures that would have been unthinkable just a decade earlier. Cancer patients, whose immune systems are often weakened by chemotherapy, could be protected from life-threatening infections. The era of modern, invasive medicine had truly begun, all thanks to these powerful new drugs. This revolution in healthcare created a sense of invincibility. It seemed as though for every new bacterial threat, a new antibiotic could be found to defeat it. The world was transformed from a place where a simple infection could be a death sentence to one where many of humanity's most feared diseases were being brought under control. This period of discovery gave us the longer, healthier lives that many of us take for granted today. The impact was profound, touching every corner of society and ushering in an unprecedented era of health and longevity for people all over the world. It was, without question, a true medical miracle. Just as quickly as the age of antibiotics began, scientists started to notice a worrying problem. Bacteria are incredibly resilient life forms. When they are exposed to an antibiotic, most of them die, but a few, through random genetic mutations, might survive. These survivors then multiply, passing on their resistance to the next generation. Over time, this process leads to the rise of superbugs, strains of bacteria that are immune to the drugs designed to kill them. Alexander Fleming himself warned of this danger in his Nobel Prize speech in 1945, cautioning that misusing penicillin could lead to resistant bacteria. Today, antibiotic resistance is one of the most serious public health threats facing humanity. Decades of overusing and misusing antibiotics in both human medicine and agriculture have accelerated the rise of these superbugs. Every time we use an antibiotic, we are putting pressure on bacteria to evolve and develop resistance. When people take antibiotics for viral infections like the common cold, against which they are useless, or when they don't finish their full prescription, they contribute to the problem. This has led to a situation where some infections are becoming difficult, and in some cases, impossible to treat once again. The consequences of widespread antibiotic resistance are dire. We risk returning to a pre-antibiotic era, where common infections can once again become deadly. Medical procedures that we rely on, like surgery, cancer therapy, and organ transplants, could become too dangerous to perform because the risk of untreatable infections would be too high. The progress we have made in medicine over the last 80 years is under threat. A world without effective antibiotics is a world with higher rates of death, greater suffering, and a healthcare system that is unable to protect its most vulnerable patients from harm. Despite this alarming trend, antibiotics remain one of the most important tools in modern medicine. They continue to save millions of lives every year, protecting us from dangerous bacterial infections. The key to preserving their power is responsible use. We must all work together, doctors, patients, and farmers, to use these precious medicines wisely, ensuring they are only used when necessary and as directed. At the same time, scientists are working hard to discover new antibiotics and find alternative ways to fight bacteria. The accidental miracle of antibiotics changed our world for the better, and now it is our shared responsibility to protect it for the generations to come.